Hello my dear children, welcome to my channel Swati Sir Chemistry. Till now we completed 25 important questions. Now the remaining 25 questions I am going to give in this video. You can see here, these are the first question. There is another question which I have given. Which of the following is maximums or is soluble in the water? But if you want to check the maximum solubility of the water, and it is coming from S block element, that is the solubility of the sulfate of alkaline earth metal. So which of the following is maximum soluble in the water? See beta, if the attraction between the two ion is less, that will be more soluble, and if the attraction between the two ion will be more, that will be less soluble. So one small trick we have to apply here. Sulfate, it is a larger size of the anion, and beta here barium, it is a larger size of the cation. But a larger the size of the cation, larger the size of the anion, they are having a strong force of attraction. It is a rule. Larger the size of the cation, larger the size of the anion, they are having a strong force of attraction. Stronger the force of attraction, less the soluble. But just reverse of it. What is that? Larger the size of the anion and smaller the size of the cation, obviously it will be more soluble. So answer is, which of the following is maximum soluble in the water? Means we can say magnesium sulfate is more soluble in water. So if we talk about the solubility of alkaline earth metal sulfate down the group decreases, that means magnesium sulfate will be more soluble. This is a question. For answer this one, magnesium sulfate. Now select the correct match about group 14. What is the correct match about the group 14? Carbon form more acidic oxide. Yes, we know beta. Carbon is forming more acidic oxide. Example, acidic oxide of carbon is CO2. Lead commonly found in +2 state. Yeah beta, lead can be having a +2 and +4, but in that one +2 will be more stable due to inert pair effect. Yes. Silicon germanium used as a semiconductor. Yes, silicon germanium will be used as a semiconductor. We can say option 4th is correct here. That is all the above. So we can say D option is correct here. Question number 28 now. Which of the following cannot decolorize acidified KMnO4? But decolorization of acidified KMnO4 means, in this case, my Mn it is in the +7 oxidation state. But Mn it is in the plus oxidation state means it can undergo reduction. But if it will undergo reduction, the other ion should undergo oxidation. We'll see here. Oxidation. They are asking cannot. But Fe in FeSO4 it is in +2, and we know +2 can be converted into +3. But it can undergo oxidation means Mn undergo reduction. Yes. Here we can say FeSO4 can decolorize KMnO4. They are asking cannot. Okay. But in SO2 sulfur oxidation state is in the +4, and we know sulfur can oxidize to +6. But when sulfur can undergo oxidation, obviously my Mn will undergo reduction. That means SO2 can also decolorize potassium permanganate, acidified potassium permanganate. Another one we are having iodide beta. It is in -1. It can convert into I2 0. But iodide from -1 to 0, it can undergo oxidation. That means permanganate can undergo reduction. It can decolorize. But CO2, carbon in CO2 will have +4. And as we know, beta, carbon belongs to 4th group. Its maximum oxidation state is equal to +4. Right? It can undergo reduction. It cannot undergo oxidation. So beta, it can also undergo reduction. It can also undergo reduction means our answer should be C. That means CO2 cannot decolorize acidified potassium permanganate. Hard water doesn't contain what? But hard water, two type of the hard water is there. What is that? A permanent hard water and temporary hard water. This temporary hard water due to the presence of bicarbonates of calcium and magnesium, but permanent hard water due to the presence of chloride and sulfates of calcium and magnesium. So hard water doesn't contain, I'll tell you better, bicarbonate, sulfate, sulfate, sulfate. Now which one it does not contain means, It contains the calcium sulfate, it contains the magnesium sulfate, it may contain the calcium chloride, it may contain the magnesium chloride. That means it doesn't contain, yes, it doesn't contain barium sulfate. Question number 30 beta, you can see, for which of the following the unit of the rate constant and the rate of the reaction same. But a rate constant and rate of the reaction same means R is equal to K. And do you know R is equal to K can be only be possible if the order of the reaction is a zero order reaction, because you know if R is equal to K into concentration of A to the power of 0, a to the power of 0 means it is a zero order. So R is equal to rate constant K. So unit of the rate constant, that is a K, and rate of reaction, that is R, both are equal only when the reaction is of zero order. So our answer should be A, called as a zero order reactions. See, but it's a very simple questions are there, but it is the most important question that I will feel. Another one, density of an ideal gas is given as a zero point 0.03 gram per cubic centimeter. Density is given, pressure is given, RMS they are asking. But how to get the RMS? I will try to find out on this part. Because it's a calculation part, I should show you how to do this kind of the calculation. It's a very simple calculation. But even in the final NEET also we are getting this kind of simple calculation. We won't get any difficult level of the calculation. Don't worry about that. This time definitely we are going to get a very simple paper. See here, RMS they are asking, you know, CRMS. But a CRMS, it is equal to under root of 3RT by M, that is equal to under root of 3PV by M, that is equal to under root of 3P by D. Yeah, but a P by D. So as we can use this one because pressure and density is given, so we can say CRMS, it is equal to under root of 3 into, but what is the value of pressure I should give? 10 to the power of 6 dyne per centimeter square. Yeah, 10 to the power of 6 dyne per centimeter square. So we can see here it is a 10 to the power of 6 by, what is the value of a density they gave? Yes, 0.03. It is under root of 3 into 10 to the power of 6 by 3 into 10 to the power of minus 2. Minus 2 become plus 2 under root of 10 to the power of 8. That means we can say CRMS is equal to 10 to the power of 4 centimeter per second is a value. 10 to the power of 4 means this is the option D is only correct option we are getting. How simple it is. Yes. Now, which of the following does not show optical isomerism? But it's a very important, this kind of question they will ask even in the exam also. Does not show optical isomerism. But I will tell you it's a very simple method is there for finding out the optical isomerism. See here, one rule will applicable and just you have to try to follow that rule. What is that? Which of the following does not show optical isomerism? But the first one is they have given it is a CO, cobalt, and it is a oxalate, and it is a minus of 3. But I first try to convert in this form. Metal M, it is a bidentate ligand, that is a taken 3 times. But we know it is a central metal atom, it is having a octatal complex. This bidentate ligand is this one, another bidentate ligand will come on this one, bidentate ligand will come on this one, because oxalate mean beta, that is a carbon double bond O bonded with carbon double bond O, right? And you know this A and A means it is a symmetrical bidentate ligand. It is on, suppose it is on x-axis means it should be on y and it should be on z. If you want to cut into two equal half, but it is on the board, we are able to see, we are able to cut into two equal part, but it is not possible. But it is a on the x-axis, that side on the top, it is on y-axis at the bottom, and it is on the plane. That means we can say plane of symmetry absent. So as the plane of symmetry absent, we can say the compound is a optically active compound, means this compound can show optical isomerism. But in the question, did you saw what they're asking? Which of the following does not show optical isomerism? Anyhow, first one will show the optical isomerism. Come for the second one now, beta. Second one. What is the second one? You can see here. Second one is given here. Second one, that is a central metal atom chromium, then ethylene diamine. En is ethylene diamine, ammonia taken 2 times plus of 3. Convert into beta this form. Central metal atom, that is a M. It is a symmetrical bidentate, it is a capital AA. Beta it is a monodentate, so written as a how many? 2 times. Right? Now here 2 plus 2 4 are there. Beta we can make in this way. What is that? 1 2 3 4. See, symmetrical bidentate here and this A and A is here. But if you want to break into two equal half, here also plane of symmetry will be absent. But on the board you are able to see, sir, plane of symmetry present, but no, plane of symmetry will be absent because it is on x-axis, means it is on backside of the plane, it is on the above of the plane. So we can say plane of symmetry absent. And compound will have a optical activity. It can show optical isomerism. But option number now C. What is that? Option number C. It is a cobalt. See what option number C. It is a cobalt. Then it is having a ammonia taken 3 times Cl 3 times. It is a central metal atom. It is a monodentate, means written as a A3. Monodentate written as a B3. But A3B3 will have a isomers called as a FAC and MER. Facial isomers, and meridional isomerism can be shown by this one. Which one, beta? That is A3 and B3. But now we'll try to make this one. It is a M1. But one trick is there. Instead of doing this way, one trick is there. Okay, it is a M. 1, 2, 3, 4, 5, 6. What I will do, beta? I will do here A and A. Right? Another one, but I'll put here as a B and B. Then I'll make it as a and A3 and then B3. But instead of drawing the diagram, we'll go with one small trick is there. I will tell you. Make a pairing of it. A, then beta A, B, then again B, B. It is a one. One more pairing we can make, beta. A to B, A to B. That is AB and AB, and this AB I'll write here. Is it clear? So these components can show two geometrical isomers. But in that one rule is there. Whenever these kind of the pairs are repeating, like a AB pair repeating, or AA or BB pair is repeating, that compound is the optically inactive. See beta, BB is there, optically inactive. AB pair repeating, that also become optically inactive. Right? So I can say does not show optical isomerism means option C. It can shows geometrical isomerism, but it cannot shows optical isomerism. But if you want to learn the particular topic about the isomerism and all, please you can send me the request. It is there in my YouTube uploaded. And if you required, but I will share this particular video with you. Now D option, metal atom M beta, bidentate ligand AA, then A2 and B2. If you see here, it will have the cis and trans, where one will show optical activity, one cannot show optical activity. So overall, this is a complex compound. It will shows geometrical isomerism, but it cannot shows as the optical isomerism. So answer should be option C. Now come for the question number 33. But which of the following oxide is a amphoteric oxide? But it's a very simple to remember which of the following oxide is a amphoteric. Beryllium oxide is amphoteric, zinc oxide is amphoteric, lead oxide, both PbO2 and Pb2O3 both are the amphoteric. So we can say PbO2 is the amphoteric oxide. Option B will be correct here. When copper is heated with the dilute HNO3, it produces what? But if you can see in my YouTube, it was uploaded a short I uploaded there. What is that? Zinc with the dilute nitric acid gives rise to what? Zinc with the conc nitric acid gives rise to what? Copper with dilute nitric acid gives rise to what? And copper with a concentrated nitric acid gives rise to what? I'll show you that one. See beta, this kind of the thing you have to remember in this way. Suppose if we are having a metal called as a zinc, or we are having a zinc, or we are having a copper and copper. See beta, if it is a zinc with a dilute nitric acid, what it gives? Zinc with a concentrated nitric acid, what it gives? Copper with a dilute nitric acid, what it gives, and copper with a concentrated nitric acid, what it gives. See, but all they are giving their salt. What is that? ZnNO3 taken twice, ZnNO3 taken twice. Here CuNO3 taken twice, CuNO3 means all are giving their salt. Zinc nitrate, copper nitrate. But if any metal are reacting with a concentrated nitric acid beta, it gives rise to the gas called as a NO2 gas and NO2 gas. But now question is zinc and copper beta. Zinc and copper. See, copper will dilute. But if copper will dilute, it gives rise to gas called as a NO gas, and zinc will dilute, it gives rise to gas called as a N2O gas. This is a small trick you remember beta. It is a very important topic that definitely in this exam they are going to ask you in your NEET exam. Right? So answer is that if copper with a dilute nitric acid, copper with dilute, NO should be there. Yes. Copper nitrate with NO means option B will be correct here. Right? Take a screenshot, beta. Please take a screenshot. Now, remaining question I am going to upload in my next video. Please take a screenshot. Hello, beta. Now, remaining questions are there that we are going to discuss here. You can see here. Which of the following will not give N2 gas on heating? But as we know that barium azide and sodium azide, it is given in our NCERT statement. Barium azide and sodium azide on heating gives rise to pure N2 gas, but they are asking which cannot use N2 gas on heating. So ammonium dichromate on heating gives N2 gas, barium azide on heating gives rise to pure N2 gas. But here ammonium nitrate on heating, but it gives rise to N2O gas plus 2 moles of water. But this ammonium nitrite on heating, it gives N2 gas plus 2 moles of water. Means ammonium nitrate gives N2 gas, ammonium dichromate gives N2 gas, barium azide gives rise to pure N2 gas, but ammonium nitrate on heating does not give N2 gas. Instead of that, it gives rise to N2O gas, laughing gas, nitrous oxide gas. Right? The answer will come here as a option B is correct. Come for question number 36. The method of zone refining of metal is based on the principle of, you know what a method of this zone refining, it is used to prepare the ultra pure metal, semiconductors ultra pure metal. That means we can say germanium, boron, silicon, gallium. Here beta, germanium, boron, silicon, gallium, indium. These kind of the metals can be purified with the zone refining. And for that one, what we can say here, you can see better greater mobility of pure metal than that of impurity. No. Higher melting point of the impurity than that of the pure metal. No beta. Greater conductivity of solid than that of impurity. No. Greater solubility of the impurity in the molten state than in the solid state. Means greater solubility of the impurity in the molten state than in the solid state. Means solid state will have a less solubility of the impurity. Hence we can say method of zone refining of metal is based on the principle of fourth option. So we can say our option number D will be correct. Question number 37. A metal crystallizes in BCC. Beta BCC means you know Z effective of BCC is 2. Its a unit edge length is given 3 angstrom and molar mass is given 60 gram per mole. What is the density of the metal? See beta, density equal to Z into molar mass by Avogadro's number into A cube. What is the A cube beta? Volume of the unit cell. Value of Z we can see it is having 2 into molar mass is given as a 60 gram per mole by Avogadro's number. 6.023 into 10 to the power of 23 into a cube. But 3 Armstrong is there. 3 into 10 to the power of minus 8 centimeter and taken as a cube. But I just use solve it here. 3 into 10 power of minus 8 cubic centimeter and all. By solving the answer I am getting here as a 7.4 gram per cc is the density of this particular metal. 7.4 cc. You can see here first option beta, option A will be correct here. See beta, in solid state every time we are getting the question based on this part. Either they will ask us to get the density or sometimes they will ask us to get the formulas of the compound. They will say it is a unit cell and these are the atoms present at the corner, at the center, at the face center. And one more possibility question from the solid state, they can ask about the nearest distance and all. So please go through it. Now question number 38, calculate the E naught of the reactions. Right beta? Copper undergoes oxidation and silver undergoes reduction. They are asking it the equilibrium constant for the reaction. Sorry beta. They are asking equilibrium constant value they gave 4 into 10 to the power of 15 at 298. What is the E naught value of the reaction they are asking. But in this case where E naught value is given, equilibrium constant is given and E naught is asking means you know the formula. What? Just a minute. I'll clean this part here. Let us see here. Calculate the E naught for this reaction if equilibrium constant is given. But then the formula is that E is equal to E naught minus 0.059 by N into log to the base 10 Kc. For equilibrium beta E value becomes 0. So we can say E naught minus 0.059 by N into log Kc. Beta at equilibrium E value becomes 0. So we can write now these terms will come here 0.059 by N into log of Kc equal to E naught. That means E naught equal to 0.059 by N. N की value 2 beta see plus of 2 plus of 2. It loses 2 electron, it gains 2 electrons. So transfer of electron is equal to 2. So N value equal to 2 into beta log of, you can check the value of Kc is given 4 into 10 to the power of 15. Beta we can solve it 0.059 by 2 into, beta it can be written as a log A plus log B. Log 4 means it becomes log 2 square. So 2 log 2 plus 15 log 10. But it become a 2 into log 2. You know log 1 value equal to 0, log 10 value equal to 1, log 2 value equal to 0.3010. So I should say 2 into 0.3010 become 0.6020 plus 15. It becomes 15.6020. So now you can solve it better here. E naught equal to 0.059 can be written as 0.6 by 2 into 15.6. And you can solve it at this value E naught is equal to plus of 0.46 volt we are getting. 0.46 volt means you can see option C will be correct. See with another equation E equal to E naught minus 0.059 by N into log to the base 10 at the concentration of product by reactant, or directly that we can say as a product by reactant can be taken as a QC or the Kc. Kc is at the equilibrium. Question number 39. I'll clean this part better, then we'll discuss this one. You can see here now. See beta, question number 39. In 39, we are having in Bohr's model of an hydrogen atom, what will be the shortest wavelength in the Balmer series? But you know it is coming from our atomic structure, that is a wavelength. So we know wave number is equal to 1 by wavelength. As they are asking wavelength, so 1 by wavelength equal to R into 1 by n1 square minus 1 by n2 square. But if the series is a Balmer series, your n1 value should be 2, and if it is a shortest wavelength, your n2 value should be infinity. Yeah, beta. Shortest wavelength for any series, the n2 value should be infinity. Then we can say 1 by wavelength equal to r into 1 by n1 square means it become a 2 square, n2 is infinity, it become a r into 1 by 4. But a wavelength equal to 4 by 1 into 1 by r. Remember, 1 by r value is 912 Armstrong because r is a Rydberg constant 109677 centimeter inverse. Instead of that, if it is a 1 by r, 912 Armstrong. Then put up here r equal the wavelength equal to 4 into 912 Armstrong. It becomes 4 2s are 8, 4, 9, 4, 36 Armstrong. So wavelength is equal to 3648 Armstrong. You can see better. This is there on the option B, second one. Which of the following is a complete combustion of methane? Yes, but oxidation of methane means this is kind of a selective catalyst. Methane oxygen. If we use the copper as a catalyst, we'll get methyl alcohol. If we use molybdenum oxide as a catalyst, we'll get formaldehyde. But here incomplete combustion of the methane gives rise to carbon black. Complete combustion of methane, it gives rise to what, beta? Carbon dioxide and water. That means complete combustion of methane is option D is correct. Right? Chalo, take a screenshot. Now we're on the list. Next question you can see here. Question number 41. Which of the following can be hydrolyzed at the fastest rate? But you can see here, it is a type of the RCOCl. RCOCl. This is a RCOCl. RCOCl means acyl halide. But just generally you consider if it is a acyl halide means it is a R C double bond OCl. Hydrolyze means in water molecule OH minus is there. It will attack on the carbon, pi bond shifted back, is negative charge, it will come here. Cl is a leaving group, it goes off. Means overall in this hydrolysis part what you have to consider, your nucleophile should attack on the carbon. If the carbon is having a more positive charge, our nucleophile can attack on it easily. If the nucleophile attack it on easily, it can be hydrolyzed easily. Now question is that among these all, among these all carbonyl carbon, which carbonyl carbon will get a more positive charge? But on this case, this is a donating group. It will have the plus M group. So it cannot create the positive charge on it easily. It is also having a plus I group. Plus I group means donation and they will give the electron to this carbon and this cannot create the positive charge easily. So anyhow these two will be ruled out. But a NO2 it will have a strong minus M as well as minus I, and here RCO group will have a only minus I, or we can say it is having minus M. But among this NO2 and this RCO C double bond or acyl group, NO2 will have a more minus I, and because of that we can say it can create the positive charge on this carbonyl carbon easily, where the OH minus ion of the water will attack on it easily and it can be hydrolyzed at the fastest rate. Come for question number now 42. But in question number 42 we can see here, but I think voice because of technical issue you are unable to listen this one. Once again I will tell you question number 41. Which of the following can be hydrolyzed at fastest rate? But in this fastest rate what is given there, RC double bond O Cl acyl group, and but in the acyl group, this is a acyl group The group which can create the positive charge on this carbonyl carbon means here pi bond will shift it back, it will form the positive charge and OH minus of the water can attack over it. Means which can develop the positive charge on the carbonyl carbon that water molecule can attack it on easily. That means it will have a fastest fastest or we can say it is can be hydrolyzed at the fastest rate, right? It can be hydrolyzed at the fastest rate. Now you can see here in this case, but a carbonyl carbon attached with the group, this group will have a donor plus I. So they cannot form the positive charge easily. But it is a carbonyl carbon attached with the OCS3. You know, OCS3 will have a plus M effect. So this plus M is donor, this plus I is donor, and this electron donating group cannot create the positive charge on the carbonyl carbon easily. Come for the option C and D. Because CS3 effect, right beta? This will have the withdrawing effect, this will have withdrawing effect, but among these two NO2 will have a more withdrawing effect, so NO2 can create the positive charge on the carbonyl carbon easily, and our water molecule, water means OH minus of the water, can attack on the carbonyl carbon easily, and this compound can be hydrolyzed easily. 42 beta. Now once you see here 42. Now next question beta, here you can see next question. Aniline with sulfuric acid gives rise to product. What is the product? If it is sulfuric acid mean, it is going to provide the H plus ion. NH2 में this lone pair, it will take the H plus ion. As it will take the H plus ion, it will get the NH3 plus. The remaining HSO4 minus will attack over it. That means our option, we can say here, the first option will be correct. NH3 plus HSO4 minus. This is the first option we are getting with this one, right? Now come for the second example now. Question number 43. Here option A is correct. Position of bromine in the compound given. See beta, in this compound, what is the position of bromine? Carbon double bonded carbon bonded with a carbon is called as a allylic carbon. This carbon will be called as a what? Allylic carbon. And but allylic carbon is having a bromine. The position of bromine is a what? At the allyl carbon. Answer first option. Right? It is a allylic carbon we can say, or it is a first option. See beta, answer for this one is A, and answer for this one also, that is A. Which is used in the paints? Very simple question beta. Novolag can be used in the paint. But Bakelite is a thermosetting polymer, and your Teflon, that is Teflon, is nothing but the polymer obtained from the, yes, tetrafluoroethylene. Dacron is a name of the polymer called as a terylene, which is made up of a ethylene glycol and teremethylic acid. Come for question number 45. Stability of plus 3 oxidation state among all. Do you know what are these? All the group element of the 15th group element, and general configuration of 15th group element is NS2NP3, means it will have plus 3 and plus 5 oxidation state. But as we are coming down the group, stability of plus 3 increases, but stability of plus 5 decreases. They are asking stability of plus 3, obviously increases down the group. Phosphorus, arsenic, antimony and bismuth. So this is the correct order of stability of plus 3 oxidation state given by Nicogen's 15 group elements. 46 beta. Calcium carbide on hydrolysis gives rise to X. Do you know X is nothing but the acetylene gas? But ethyl chloride with alcoholic KOH. See, alcoholic KOH act as a dehydrohalogenating agent. Means removal of halogen and hydrogen, but it gives rise to alkene. That is CH2CH2. But X is the acetylene, Y is the alkene. Acetylene means C2H2, converted into C2H4 only by addition of hydrogen. Addition of hydrogen called as a reduction. But a concentrated sulfuric acid acts as a dehydrating agent. It is a strong reducing agent. We don't require here. PD with BSO4, yes, it's a Lindlas catalyst, can be used for the reduction. And zinc amalgam conc HCl, yeah, but it is a Clemmensen reduction. We don't want. So directly with PDBSO4, the C2H2 can be converted into C2H4. Question number 47 here. Identify a molecule which does not exist, but everybody knows that. Find out the bond order. If the bond order of the molecule 0, that molecule does not exist. But simple way that all the noble gases are the monoatomic molecule, and monoatomic molecule never exists in the molecular form. So we can say, but we don't have monoatomic here. So better find out the bond order. But a nitrogen N2 molecule will exist, we know. Lithium atomic number 4, sorry, atomic number 2, sorry, lithium atomic number 3, 3 plus 3, 6. Configuration can be written for this one, beta. How? Sigma 1s2, sigma star 1s2, sigma 2s2. Beta bonding how many? 2 plus 2, 4. Anti-bonding how many? 2 by 2. 2 by 2, 1. Means we can say yes, Li2 will exist. Beta Be2, atomic number of beryllium 4, 4 plus 4, 8. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Bonding beta 2 plus 2, 4. Anti-bonding 2 plus 2, 4. Bonding minus anti-bonding 0 by 2. Overall 0. We can say this option C does not exist. Yeah, beta. B2 molecule does not exist. Come for question number 48. Identify identify the wrongly matched pair. But in this one, PCl5, find out the value of Z. In PCl5, Z value is equal to 5. 5 means it is a sp3d. That means it is a trigonal bipyramidal geometry. This is trigonal planar. Wrong. The first option, PCl5, is a wrongly matched. But a SF4, sulfur Z value equal to, yes, 5. 5 means sp3d, trigonal bipyramidal geometry. But due to presence of one lone pair, if you see, the shape become a seesaw. Another PCl3, yes, trigonal pyramidal. XCF4, 2 lone pair, 4 bond pair, square planar. All are correct except PCl5, which is a wrongly match. Right? Take a screenshot of this one. Part. I hope now you are able to hear me. But these are the last two questions are there. That already I promised that these are the few important questions or the 50 questions from all 30 chapters for chemistry first year and second year. I have discussed here on the board. So this last question is left here now. We will discuss that one. And afterward, within 3 days, I mean to say, uh, on 11th or on 12th, I am going to again upload one more as a NCERT golden line. But a NCERT golden line means in that every chapters some important lines are there or important points are there. Just I will upload that part and I will ask you go through that important point, that if you'll revise that one, definitely it is not only 100%, it is a 200% you are going to get the questions in your NEET exam on July 17th, which one you are having, right? Chalo, we'll discuss this part, and that to be maybe on 11th or 12th I am going to upload you and you will get the notifications and all. Now see here, halogens having the greenish yellow gas. But a greenish yellow gas means everybody know chlorine gas. Yeah, but a greenish yellow gas is chlorine gas. And this chlorine gas on reacting with hot concentrated NaOH, it gives rise to product. But we know that when the chlorine on combining with the hot and concentrated NaOH, 100 H by C, hot and concentrated NaOH, it will be converted into NaCl plus NaClO3, remaining byproduct and all. But here chlorine oxidation number 0 and here it is -1 and here it is +5. 0 to -1 and +5. That means we can say our option number D is correct here, right? 0 to -1 and 0 to +5. That is a change in the. I think still you are unable to hear me. Last once again, see beta. What is that? A greenish yellow gas is given, and this greenish yellow gas on combining with hot and concentrated NaOH, what happen? It gives rise to following product. Greenish yellow gas means chlorine. Reactant hot and concentrated NaOH means this one, but it gives rise to NaCl plus it gives rise to NaClO3, and we can see oxidation number of chlorine 0, here -1 and here +5, changes from 0 to -1 and +5. Option D will be correct here. But the last question you can see, distribution of electron in the metal ion of Mn2 6 times +2 in splitted the orbital is. But you know Mn, oxidation state of Mn, it is in the Mn+2. You know atomic number of Mn is what? Yeah, 25, 4 is to 3d5. By losing 2 electron, its configuration become only d5. So we can say d5. But even you can see water is a weak field ligand. And you know, as we are having this one T2G, this is called as a T2G, this is called as a EG. But we are having 5 electrons, so 1 2 3 4 5, because if it is a water is a weak field ligand, for this one our electrons can go from T2G orbital to the 2 electrons, remaining 2 electrons can go to the EG orbital easily. Why? Because in the weak field. Hello, as a, I think you are able to hear me. But now d5, and in this one splitting of orbital will take place in this way. That means T2G3 and EG2, because 5 electrons are there. All the 5 electrons can distribute in this way. 1, 2, 3 and remaining 2 goes up, because in this case pairing energy will be more. And you can see the option number T2GE3. Here we have T2G3 EG2. That means our option B will be correct, right? So beta, these all are the important questions for this coming NEET exam. I am expected, and really in that all 30 chapters, these are the very important questions that I have discussed in the class. But on 11th or 12th, I am going to upload NCERT Golden Lines. Please go through it and try to see that one. Definitely it will help and boost up for your this NEET exam. All the best. Thank you, beta. Thank you very much. Thank you very much, beta. All the best. Take care. Bye.